We are now talking about 3.5 using Boxplot for displaying summaries. So in this section, I will talk about file number summary. What is file number summaries? Is minimum Q1, Q2 is minimum, right? And Q3 and maximum. So in order to get all of these numbers, all of these file numbers, you can use TI 83 or 84 with using the function as one var start to get it, right? And I will show you later also for that. And we also gonna have the StatCrunch videos for this later. So let's have some review from before. First, in order to identify the unusual observations with symmetric data, we're gonna use z-score. You can take a look at section 3.2, okay, to see that. And for potential outliers, so with the non-symmetric data, you can we're gonna use a fence we're gonna talk about it in this section 3.5. Okay, so let's start and recall about some things that we learned about interquartile range in the previous session, which is IQR is going to be Q3 minus Q1. So keep in mind that in order to find the outlier, we need to follow 3 steps below. First, you need to find IQR, and then you will have to find the lower fence in order to find the outlier. If the outlier lower than this fence, right? Okay, then it's going to be the outlier. I mean, if the data value is lower than this fence, then it's going to be outlier, right? The lower fence will be calculated at Q1 minus 1.5 time with IQR. This time, I mean, my bad. Let me try to clean the X here. Okay, it's me time better. Okay, so time. Yep, time 1.5 times IQR. Okay, so for the upper fence, you will use Q3 and plus with 1.5 times IQR. Okay, so so that is a way to compute the lower fence and upper fence. If I have like a number line, okay, you guys know that for let's say here is a mean as Q2, then here's Q1, here is Q3, let's say that, right? Let me see, let me change. Then we know that we know that if you take Q3 minus Q1. You will get the IQR over here. Yeah. And so then the data that and so then I'm gonna have like a fence, say left fence, a lower fence. Use that color, lower fence. Yeah. You will do like 1.5 times with IQR, and then you use Q1 minus for that value to get the lower fence, and same things at the other hand side, but you want to use Q3 but it plus. So that means the upper fence will be above the will be outside, like high in the right hand side of Q3. Okay, so okay, so if you have some value that's greater than upper fence, they are outlier, or less than the lower fence, then they are outlier here, right? Outlier. Outlier. Okay. So let's move on and do this. Any value that less than lower fence or greater than upper fence, they are outlier. Okay. And you see in the picture that I provide, we have right now look like we have 4 outliers. Okay. So let me move to example number 1. Okay, so let me move to example number 1 and see that. Okay. So we need we keep working on the problem with CO2 emission, and we're gonna find the file number, summary, and then find the IQR. So I would say I'm gonna show you by TRA3 for this one, right? So click on for this, right? And then start, edit. Okay, so make sure that I did have a list of all the data values for example L1. So it was L1, and you see here, right? So I will move to the count C here and make sure using one VAR stats and the VAS. Okay, so you will use at least L1. Okay, so you click second and L1 here, right? And the VAS, you will have the file number, file summary number as at the next page. So pull down and you will see mean X there, which is minimum. Okay. The Q1 1.61 there, right? And then median is Q2 2.165, Q3 2.68, maximum of X 6.81. So so that's gonna be it. All right, so let's let we just type down all the output that we have from the calculators. So I have minimum equal to 1.01. Then I have Q1 is 1.61. Medians is 2.165. Q3 is what? 2.68. And the maximum is 6.81. So you can find QR by using the two values as Q3 minus Q1, right? So I want to use Q3 is 2.68, and then minus for Q1 is 1.61. And that's going to give me as 1.07. You can use the calculator to check that. All right. So you have IQR, you have 5 number summaries, okay? And then what is outlier? So let's follow the we're gonna just follow by the formula of outlier to find the lower fan and upper fan. Okay, so we have Q1 1.61 minus for a parentheses 1.5, and then it's time with IQR. So I'm gonna put time and start there. Okay, IQR is 1.07. All right, what is that equal to? Use a calculator to handle that. Okay, so if you have TI 83 or above, this is gonna be great to practice. 1.61 and minus with parentheses 1.5 times with 1.07. Okay, I mean, you can take away the parentheses because we do multiplication first, and then after that we can do the subtraction there. But so then that's the reason why we don't need the parentheses here, right? So enter this, you have like 0.005 as the answer. So that means what? Every value that's less than 0.05, 0.005 gonna be the outlier, right? Do we have any values that's less than 0.05, 0.005? Right. So according to all the data values above, we have no values less than lower fence, right? It is 0.005. Okay, so no outlier in the left hand side. Okay. Now, what about the upper fence? We have Q3, so you use Q3 2.68 plus with parentheses 1.5 and time which IQR is 1.07. You can use the calculators and you should get 4.285. Okay, so so you have upper fence will be 4.285. Do we have any number that's greater than it? I saw a number over here that's greater than it. I saw another one here. All right. So look like we have two values that greater than 4.285. So I say 5.22 and it's greater than 4.285 and 6.81 is also greater than 4.285. And then so therefore potential outlier gonna be 5.22 tons per person, or 6.81 tons per person. Okay, so these are two outliers in this data list. Okay, so that is outlier and 5 summaries. Now I'll teach you about box plot. Okay, so let's move on. All right. So this is box plots, and sometimes statistics call like box whisker. Box whisker graph. Okay, so box plot or box whisker graph is a graphical tool for visualizing a distribution, and especially when comparing two or more group of data. So it's really helpful for the case when you're comparing two or more group of data. Let's say benefit of it's going to be show a typical range of values, the potential outliers, and variation to compare. And the drawbacks is do not show the it do not show the modality, the mean, or work for a small data set. So that is the drawbacks. Okay. All right. So let me see. Okay, so let's move on. So down here, I have the first one, the first row in here have three histogram graph, right? That's, I mean, right here, histogram, right? And the first one, you can see it was screw to the right, or let's say screw right. And the second one is symmetric. And the last one is screw left. Yeah. So I also provide from the graph histogram. I also I mean, actually it should come from the fine number summaries, but okay, so I have provided the fine number summary as minimum Q1, median at M here, Q3, and the maximum. Everything's on the histogram here. And now, because in this section we learn about box plots, right? So I convert these histogram to be box plots, right? And as you can see that we have the right of the let's say right whisker over here have longer, right? the right. Let me use the highlight here. The right whisker over here is longer. So right whisker longer. Okay, so in histogram it was screw to the right, and in Boxplot you can see the right screw is longer. The right whisker is longer than the left one. So you can also notice that the mean the mean value is that from like from the first part there for the line, let's go to the middle of the box, right? And then the box start from Q1, right? And inside the box, I mean, and in the box length and go length is actually like IQR, but the box has the last part as Q3, right? And in middle of the box, it's have like a line that split the box to be two pieces, and that line is gonna be the value of the median. Okay. So look like whisker box plot is it is like it using all the values from find some summary number, and it start from like a line initially as the minimum values go through the box that's that from Q1 to Q3, and then and then we have like a right side of it is continue with the line until the maximum. So that's the way we draw the box plot by hand, right? You can also compare the other case such as symmetric there, right? And you can still see that for symmetrics histogram, when you convert it to the box plots, you see that the whisker of two sides is equal each other, so the length is equal, right? Equal length of whisker, right? So let's say equal length whisker. And yeah, and the last one have the left whisker longer, right? You know. All right, so now you're gonna say, oh, how can we draw the box plots on TI 83 or 84? So here is a way to go with it, right? I can go ahead and show you, and I'm going to use the data from the CO2 examples, right? So we start with quick stat, and then enter to go to the edit. I do that. We finish the data set for L1, right? So so now we're gonna move to second Actually, end this. We will do second, and then go to y equal to here, which actually is gonna give us that stat plot. Then intertwine to intertwine to open on what? Here. To open and turn on +1. Okay, so enter one more time and then turn highlight the on here. That's what they need. Okay. And then what they need us to do, select type that look like box plot with the outlier. So if you see there's the type that's look like the box plot. The first one have 2 dots in the right. The second one have just the box plot, the box, right? Box and the whisker. So because we're looking for the outliers also, I will gonna use this one, right? And also it say like lower left and push enter. So this one gonna be the one that we're looking for. So enter that. Okay, so they say actually we using L1 list at the data of CO2, and then it says zoom 9. Okay, so click on this one. I think that's gonna be it. Yeah, let's follow them. I know that we're gonna click grab here, but let's see what's happened. So click zoom here, and then go to the 9, zoom start, right? Here you go. So now it show me the box plot, right? It show me the outlier here. But let's say how can we read the value of it? The value of on find some number summaries and the outlier, right? So you click chase, you see that the minimum going to be 1.01, and click to the right, going to be Q1 1.61, right? And so on, right? Q3 maximum outlier is here 5.22 and 6.81. So that's is way using calculators, okay? And yeah, I think example 2 here is exactly what we just did. Okay, what we just did. So I can just skip example number 2. All right. So now we move to example number 3. So let's say after you have a box plots, and you want to interpret it, right? So let's say here is a box plot of the exam score, and you want to know what was the median exam score, right? So you will look at the middle line in the box, the line that in the box, right? So that's going to be the median. Median is here, right? And so what is that? It's going to be 81. Sorry, 85. So median is equal to 85. Okay, is 85 point, right now. And say what was IQR? So you need to find Q1 and also Q3, and using the formula as Q3 minus Q1, right? So I have IQR equal to Q3 minus Q1. Q3 is 92 minus Q1 is 83. You get 9.1. Okay. So C say what exam score was a potential what exam score was a potential outlier. So look at the dot that outside of the whisker plot here, right? Outside it, you see the dot at 68 there, right? So that's gonna be the potential outlier, 68. And what percent of the students score below 83? So below 83 is Q1, right? And Q1 is, you guys remember that Q1 is quartiles, the first quartile, which means like the 25th percentile. So Q minus Q1 equal to 83. So this is 25th percentile. Which mean you're gonna have which mean therefore 25% of student score below 83. That makes sense? All right. Okay, so that's D. What about E? What percent of students score between 83 and 92? So 83 and 92, which is IQR, and IQR is called about 50% of the data values. So so you can just say 50% of student in between. Between 23 and 92, right? So that's gonna be it for E. Okay. Highlight here, outline. This is minimum. Moving the maximum. All right, so we done with example number 3, and let's move to example number 4. So this example number 4 is talking about true or false, right? And we're comparing box plots. We have 2 box plots here. One is San Francisco and the other one is Provo. And this is talking about the temperature, right? Okay, so let's say both cities have similar typical temperature. Is that true or false? Keep in mind that there's a word, let me see. I like both, right? Both cities have similar typical temperature. Okay. Well, look at the so we don't look at the median, right? Because this case, we have we comparing between 2 like school distribution in here, right? So you can see that the median of San Francisco and Provo, they look, I mean, pretty similar. So I would say chill for this. Right, similar, because you can see medians was medians of the San Francisco was here, right? And I mean, compared to Provo, they pretty much the same. Okay. They say both cities have fairly symmetric distribution. Is that true? Well, look at the shape. So SF absolutely is screws to right. Yeah, I mean, for the, you can look at the whisker, right? For the Provo, you can say like fairly symmetry, that's okay. Like roughly symmetry, that's okay. But for San Francisco, no, right? So the word bold here make a false statement. False, because SF is school to the right. Okay. Next, Provo has much greater variation in temperature than San Francisco. So look, in order to compare the variation in this case, you can look as IQR, right? So we can compare IQR between two cities. And I mean, you can pretty much see that the IQR, say here's Q1, yes, Q3 of the Provo, right? And the other one gonna be Q1 here, Q3 here, to be smaller to make it. Right. So you can see that's the box, the length of the box for Provo is greater than the length of the box in San Francisco. So I will say IQR of a Provo. So the line Provo has longer box. So then it have longer IQR. So to say Provo have, so yeah, so we can say greater variation in temperature, right? So that should be true. True. Okay. For the first claim, maybe we can say something like we can see median both city pretty much the same. See that? See that, right? Okay. So maybe circle for the answer. Shoe for shoe. Right? And then I just finished section 5.5 here. We'll see you in the next chapter. We finished chapter 3 already. All right. Have a good day.